All right. Well, welcome back. Here we are. We're going to wrap up section one. We're going to talk about carrying out a test, and this is what we want to do for a chi-square test for goodness of fit is what we're going to talk about. And again, those conditions that we've seen grown so accustomed to, making sure it's random, our 10% condition, and then the large counts a little different. We want all expected counts to be at least 5. All expected counts to be at least 5 is what we want to see here. So let's see how that works. And again, when checking the large counts condition, good AP tip, be sure to examine the expected counts, not the observed, and make sure to write and label the expected counts on your paper or you won't get credit. So we'll show you what that is. And remember the chi-square test for goodness of fit. Again, we can do that with our calculator. We learned that in section 1, how to get that, not just that chi-squared value, but also the p-value, the probability of that. So we want to be able to look at that and put it all together here today. So here it is. In his book, Outliers, Malcolm Gladwell suggests that a hockey player's birth month has a big influence on his chance to make it to the highest levels of the game. Specifically, because January 1st is the cutoff date for youth leagues in Canada, where many NHL players have come from. Players born in January will be competing against players up to 12 months younger. And the older players tend to be bigger, stronger, and more coordinated. And we've all seen that in the youth. That's certainly a good point. And hence get more playing time, coaching, and have a better chance of being successful. To see if birth date is related to success, judged by whether a player makes it to the NHL, a random sample of 80 NHL hockey players from a recent season was selected, and their birthdays were recorded. And the one-way table summarizes the data on the birthdays for these 80 players, so you can see the distribution there. All right. Now, does the data provide convincing evidence that the birthdays of NHL players are not uniformly distributed across the 4 quarters of the year? There seems to be some evidence, as we can see here, but is there convincing? Let's take a look and see if that is indeed the case. Okay, so let's get into our ideas here. We're going to say that the null hypothesis is that the birthday players are uniformly distributed, and our alternative is that they are not. And so we're going to use a 5% significance level to do that. All right, so the plan is we're going to use a chi-square test for goodness of fit. And the data, as we do our check here, random, yep, it came from 80 random sample. 10%, 80 is less than 10% of all NHL players. And then our large counts. Now remember, we had 80, so we're going to say don't go by the results that we have or what we got, but go by what should happen if it's uniform. We'll take it divided by 4, so that's going to be 20. And so that is bigger than 5. That's perfectly fine. Okay, so the do part, again, we can certainly use our calculator to put this data in and compute that. That would certainly be fine. As we've kind of looked at our tech corner, you can put the numbers in list 1, and then in list 2, you're just going to put 20, 20, 20, 20 in for that. Or you can compute it this way. That's fine too. Either way, you're going to get a chi-square value of 11.2, and following up, if you're using a table, it's kind of, I maybe discourage the table use, but it's going to show you between 0.01 and 0.02. I like using the calculator better. If you go into that and put in the information here in our tests, we can certainly look at that in the VAR section. We can get that probability of 0.011, and we actually have that in there. Okay, so with the conclusion is that because of our p-value, is 0.011. It is less than our significance level of 0.05. We are going to reject the null hypothesis. So we do have convincing evidence that the birthdays of NHL players are not uniformly distributed. And you can kind of see the tendency there that, yeah, there is some merit into saying those born in January have a better chance of making it. And that might be due to those systems like they mentioned before. So that's kind of interesting on that. All right, so remember when you're carrying out that test, when we do that, again, you hit stat, you're going to go over to test, you're going to scroll down, you're going to see chi-square, and then it's going to see GOF, goodness of fit. And before you do that, as we do stat and we edit, we're going to put the actually observed data in list 1, and then what in theory should be all 20 in list 2. That's what we're going to see in there. Now, when we go to that, again, it's the chi-squared. If you hit stats test, you have to scroll down, chi-squared goodness of fit test. Make sure list 1 is the observed, list 2 is the expected. Again, 4 minus 1, that's our degrees of freedom of 3, yeah, because we have 4 counts there. And then we're going to go down and calculate. And again, you can draw it out too as well. Watch that tech video. It's really good what we do there. So I would definitely do that as well. Here we go on the next one. So when we get that and we get a calculate, we're going to see the chi-square is 11.2 with the p-value being 0.01, pointing around to 0.011 if you want to. But again, it does that. And then here's one of the interesting things that we see here is this contributing factors one, and it kind of brought out the numbers in those quarters, and you can see which ones might have a bigger contributing factor. And we're looking here at quarter 1, that's the January through March, as opposed to the October through December. Those are the ones that seem to have a little bit bigger numbers. So those are bigger contributing factors into there. So again, that's what it kind of talks about, is that it says contribution is the abbreviation there. And we'll talk about that here in a couple slides here, just to kind of reiterate what that's all about. So again, here's your tip. Now, again, you can use the calculator, which I do say you should. If you just give the calculator answers no work, or one or more of your values incorrect, you'll likely get no credit. So you got to be careful. Remember writing out the first few terms, and then talk about, and then going to the calculator and just making sure you're putting in those numbers of what you get and getting those numbers out. But it might be a good idea at least going through how to calculate so they can demonstrate that. A good exam tip there. But again, as we took a look at this, if the sample data led to a statistically significant result like ours did, we can conclude that our variable has a distribution different than the one stated. Now, to investigate how the distribution is different, start by identifying the categories that contribute the most to the chi-squared statistic. And again, as we looked at those contribution ones, you can kind of see, yeah, there's that first quarter and that last quarter seem to have a little bit more influence contributing to that as well. So we might want to pay attention to those categories to maybe mention things forward. So again, in October through December, 8 fewer players were born than expected. So that's kind of a big factor in that. In January, 12 more players were born than expected. And so you can kind of see that one of the things that they had talked about, this is kind of in support of that argument. So yeah, date of birth might have a big impact on that. So, all right, so there we go. That ends up section 1. Remember, these learning targets should be able to go there. Have some fantastic problems on 775. I would do that 9 and 13. And then those multiple choice questions 19 through 22 are always great. Okay, until next time, I'm Mr. Boone.